Hello, welcome. In this part of the lecture, we will discuss some non-separable ODEs that can be converted into a separable equation with the help of an appropriate transformation. So the equations can be reduced to separable variable equation. Consider the equation as shown in equation 6.2.1. Y prime equals some function f of ax plus b plus c. So the argument of the function f here is linear in x and y. Let the coefficient of y be not equals to 0. Now we introduce the transformation u equals ax plus by plus c. Then by differentiating u with respect to x, we get u prime equals a plus b times y prime. Equation 6.2.2. Now multiplying both sides by b and then adding a to the equation 6.2.1 and using the equation 6.2.2, we obtain a plus b times y prime equals a plus b times f of ax plus by plus c. Now a plus by prime is simply u prime by using equation 6.2.2, and this quantity ax plus by plus c is simply u. So we obtain an equation in the new variable u, namely u prime equals a plus b times f of u. Now separating variables in the last equation, we obtain this equation. Let's consider an example. Y prime equals x plus y plus 4, the quantity all squared. This is a nonlinear, non-separable equation. Let's try to use an appropriate transformation to this equation so that it can be converted into a separable equation. We define the new variable u equals x plus y plus 4. Then by differentiating this new variable u with respect to x, we get u prime equals 1 plus y prime. Now adding 1 to both sides of the given equation, we obtain this equation where 1 plus y prime would be replaced by u prime, and 1 plus the quantity x plus y plus 4 squared would be 1 plus u squared. Now separating variables in the last equation, we obtained this equation. Du over 1 plus u squared equals dx, which when integrated gives the arctangent of u in the left hand side and x plus c in the right hand side, where c is the constant of integration as usual. Now solving this equation for u, we get tangent of x plus c. Now replacing u by the quantity x plus y plus 4, we obtain this equation. And solving for y, we get the equation shown in the box. So this is the explicit solution to the given nonlinear equation. We solved it by reducing it to a separable equation.